Today I would like to explain the 12th module is deep learning. So in the deep learning, today I am explaining what are the future directions and innovations in deep learning. So deep learning is a learning from the observations from deep manner by applying number of input and hidden layers and by increasing fine-tuning parameters in order to solve real-time applications. It is an extension of machine learning algorithm, machine learning. So in deep learning, we are using very good algorithms to solve complex applications. Now I am focusing on what are the future directions and innovations in deep learning. I am going to demonstrate practicals. Okay, so this is about the syllabus of data science training. This is the 12th module. Module 12, today I'm going to demonstrate and with explanation and practicals. So the first concept is fundamentals of neural networks and what is meant by convolutional neural networks for image processing, recurrent neural networks, RNN, and long short-term memory, LSTM, transformers, attention mechanisms, autoencoders, generative adversarial networks, and followed by the deep reinforcement learning, explainable AI, XAI for deep learning transparency, federated learning, and privacy preserving AI. These are the extensions of AI innovations, and these concepts are future topics in deep learning and optimization techniques for deep learning models and deploying deep learning models in production like machine learning operations and cloud artificial intelligence. Then in this deep learning, I am going to explain, this is the syllabus of today's concept. What are the future directions and innovations in deep learning? The first concept is self-supervised and unsupervised learning. So there are three approaches we might have seen in machine learning approach, like supervised learning, unsupervised learning, and reinforcement learning. And these two concepts we are learning in deep learning, like self-supervised learning and unsupervised learning. What is meant by supervised learning? Supervised learning is nothing but there is a label, there is a target class. Based on that one, we are classifying the data. And example, in a class, based on the gender label, we are classifying the male versus female. So that is called a supervised learning, where we are using classification techniques like support vector machine, random forest, Bayesian networks, and neural networks, etc. Then unsupervised learning is nothing but there is no label, there is no target class, but I would like to classify the data based on the similarity measure. We are using Euclidean distance, Manhattan distance, Minkowski distance. For calculating distance between 2 points, we are using Euclidean distance, x1, x2, y1, y2, 2 points are there. We are using the formula square root of x1 minus x2 whole square, y1 minus y2 whole square. So based on that similarity measure, we are classifying the data. So there we are using clustering concept. Clustering is a collection of objects having similar behavior in the group. So that is called clustering. We are using clustering algorithms like k-means clustering, fuzzy c-means clustering, agglomerative clustering, density-based clustering, db-scan clustering, etc. Then what is meant by reinforcement learning? Based on the punishment and reward, we are solving the problem, and based on the mistakes, we are rectifying the errors, and that is called reinforcement learning. Especially in gaming applications, we are using n number of algorithms. Okay, and self-supervised learning is nothing but, so in supervised learning, the extension of supervised learning, that means the model itself finding what are the fine tuning parameters while performing trial and error basis method. So it applies itself trial and error method where it converges. By that learning is called self-supervised learning. Neural architecture such that is called NAS and automated AI model design. Today I am going to explain future direction of deep learning. These are the top 10 future directions and innovations in deep learning. Third one is a transformer models and attention mechanisms. Explainable AI, XAI for deep learning transparency, federated learning and privacy preserving AI, efficient green AI for sustainable deep learning, multimodal deep learning that is called integrating vision, language and audio, neurosymbolic AI combining deep learning with symbolic reasoning, adversarial robustness and security in deep learning, quantum deep learning and AI powered edge computing. So these are the top 10 future directions and innovations in deep learning. And the extensions like future directions and innovations, key innovations in deep learning, emerging research trends, what are the challenges and ethical considerations, future applications and case studies, conclusion and question and answers. So I'm expanding all this syllabus. The first module I'm going to demonstrate the first concept. This is the image of deep learning. What is the technical name of this image, Ramchan? What is the jargon of deep learning for this image? How do you can?
For example,
yes, very good,
learning
very
the deep
good.
learning
And what is the technical name of this image? Whether it is a JPEG image or any TIFF image, or what is this image we can call it
learning,
as?
mental, neural. I mean, all these mechanisms are involved in understanding the concept of deep learning.
Okay, perfect. The technical name of this image is a word cloud of deep learning. That's what I'm expecting from you. Okay. It's very good. So how do we can publicize about the deep learning? Everything we have incorporated. This is one more way of publicizing about the deep learning word cloud. Okay. Then we are moving to what are the schools of deep learning, like DeepMind. It uses reinforcement learning. OpenAI is a company. Transformers they have developed. Facebook company self-supervised learning they have developed. Google company auto ML machine learning algorithm they have developed. Apple they have developed federated learning. Microsoft machine teaching. Amazon transfer learning. IBM quantum machine learning. These are the schools of deep learning right now. All the MNCs are leading in their domains. So deep learning is, you can call it as use cases where we are using this AI for every industry, like agriculture, healthcare, manufacturing, retail industry, financial services, insurance, recycling, etc. Then what is the exact meaning of deep learning? See, the difference between machine and deep learning, machine learning will identify whether it is car or not. Whereas in deep learning, it will identify it is a car and it can give the additional features like what type of car, what is the cost of this car, what is the color of this car, what is the weight of this car, what is the everything it can describe. That's why deep learning. Are you understanding? So that means we are extracting minute level features of a complex data. Wherever complex data is there, we are using deep learning concepts. So that's why deep learning models can recognize complex patterns in pictures, images, text, audio, video, graphics, animation, other data to produce accurate insights and predictions. So that's why artificial intelligence is a big umbrella. Under that one, we have machine learning. Under that one, we have deep learning. So, artificial intelligence is nothing but science and engineering to develop intelligent based kind of applications, intelligent behavior in a machine. So, under that artificial intelligence, we have machine learning. Learning from the observational data by applying three approaches like supervised, unsupervised, and reinforcement learning algorithms. Deep learning is nothing but learning from the observational data with a deep manner by incorporating high number of input layers, hidden layers, fine-tuning parameters, activation functions, dropout, etc. With the self-supervised learning and unsupervised learning concepts. That's why deep learning is a section of machine learning methods that uses artificial neural networks as a base concept with more than 3 layers to conduct data analysis automatically. Then there is a small example I would like to explain. Reinforcement learning, how it is working. There is a small analogy, try to understand. Right side, we are having fire, and the left side, we are having tap with a bucket of water. Now, intelligent robot, what it is doing, that agent observes the environment and it observes, select action using policy. If it done a wrong step, automatically minus 50 points will reduce. Then the agent fire is there equal to bad step. Next time it is avoiding. That means the mistakes automatically it is rectifying itself. So that's why based on the punishment and reward, we are solving the problem in the case of reinforcement learning. So whenever it does good step, get reward. Whenever it does bad step, it gets penalty. So the updation policy, that means learning step automatically done. That's why it iterate until an optimal policy is found. This is a small example of reinforcement learning. See the difference between machine learning and deep learning. Just now I have explained. We are giving the same car for as input to the both models. Feature extraction, classification, car or not car, we are finding through machine learning model. Whereas deep learning model, feature extraction plus classification, we are applying hidden layers, input layers, fine-tuning parameters, dropout function, activation functions, and so many layers we are applying. Finally, we are getting output with the car, color, make, and model, like not car. See, so many features we are describing in this deep learning concept. So there is a difference between machine and deep learning in the case of factors like data requirement. We are using requires large data, whereas in machine learning can train on lesser data. Accuracy factor in the case of deep learning provides high accuracy. In machine learning gives lesser accuracy. Training time, we are getting takes longer time to train in deep learning. In machine learning, it takes time to train. Hardware dependency, it requires graphical processing unit to train properly. For machine learning algorithm, we require central processing unit. Hyperparameter tuning required in deep learning can be tuned in various different ways. Machine learning can use limited tuning, fine-tuning capabilities and parameters. That's why deep learning is a subset of machine learning that uses neural networks to automatically learn patterns from large amounts of data, where machine learning relies on human engineered features for decision making. Then these are the top deep learning use cases, especially we are using face unlock in smartphones. We are using deep learning because so many faces we are training. Then selfie filters, networking, cab booking, Hey Siri, Google applications. See, in deep learning, we are using personalized marketing, Gmail spam alert, Play Store recommendation, online food delivery portals, etc. That's why deep learning widely used in computer vision like audio, video, text, graphics, animation kinds of applications. Natural language processing, autonomous vehicles, healthcare diagnostics, fraud detection, recommender systems, speech recognition, robotics, climate modeling, and drug discovery. These are the various deep learning use cases. So this is the architecture of a deep learning process. We are having input layers L1, hidden layers L2, hidden layer L3, hidden layer L4. You can ask